So my year sevens, let's get you sorted and ready for your end of year exams. Welcome to our Year 7 end of year revision walkthrough. Guys, I'm so happy to have you as a part of my community. And you're Year 7, so I'm expecting to have you until you have finished your secondary year, because I want to be a part of your journey to help you ace those maths exam, whether it is an end of topic test or a final exam, and ultimately your GCSE exam when you get there. So guys, before you get started, it would be a good idea to download the paper. I've put that in the description of this video that you can have it printed so that you can work along to get the best experience of this session. Remember guys, it's very important you help me to grow this community. So you need to like the videos, hype the videos, and leave me a comment as we go through to let me know how useful this has been. And once you do that, together, you and I are the dream team. So guys, before we get started, I just want to say people who make a comment are likely to get a shout out in my next video. Is that going to be you? Now, with all of that being said, let's make a start in our revision. We begin with place values. Write the number 53,148 in words. So we say again 53, so 53,000 148. All right, so we read that again. So 53,148. Beautiful. We go on to the next question. We're given 23,451.96. We're asked to write the digit that is in the hundreds place. So again, we're going to read the number. 23,400, so we can hear 400. So the digit in the hundreds place is 4. Okay. Write the digit that is in the hundredths place. We know that this place is after the decimal. We know the first place after the decimal is tenths, and the second place is hundredths. Therefore, the digit that we're looking for is 6. Beautiful. So start very simple. We carry on. Another place value question here. We're asked to write the missing number on this check in the box provided. So we read 2,024,068. So we have two options here. We can either use the place value chart to help us, or we can write each number that we heard down and add them together. Writing the numbers down may be the best way to go. So let's go. 2 million. So we know million has 6 zeros. So 2 and 1, 2, 3, 4, 5, 6. 24,000, but make sure we line up our digits properly. So we know 3 zeros at the end. Let's put that first. So 24,068. So we line up 6, 8 and add them together. And this will eliminate your missing to put a 0 in or putting too much 0. So let's add them together. So in this column, we get 8. Then we have 6. 0 in the third column, 4. Then 0 plus 2 is still 2. Then we got 0 and 20. Beautiful. That's a really good way to do it. So now we have 20, 24, 0, 6, 8. And just like that, If we're going to use the place value table, we could write the digits we heard first. So we know for sure we heard 2,024,000. Four thousands. We're sure we hear 4,000s. And so 2 has to be here, 24,000. We didn't hear any 100 at all, but we heard 68. All we would need to do now is to fill in zeros in the missing space. So we got 2024068. Never again should you get writing worded numbers, words into numbers again. Beautiful. 2 marks. So we continue with powers of 10. So here are 6 cards. We can see we got a multiplication by 10, by 100, by 1,000, division by 10, division by 100, and division by 1,000. We're asked to use a card to complete each calculation. So we've got here 5.3, a calculation which that gives us 0.53. So best way to do this is to go 5.3 and see what we need to do to get 0.53. So we definitely see that our decimal has gone 1 place backwards in our answer. So if I move 1 place to the left, I will now have 0.53. So therefore, I have divided by 10 because I moved 1 place. So the card I need to use is division by 10. And then we simply tick that off. We have used division by 10. Now we have 5.3 and a calculation that will be equal to 5,300. So let's go 5.3. I need to get to 5,300. So let's see how many places. Clearly, we need to move to the right. We know that when we multiply, that's when we go to the right. So let's see how many times we need to go. So 1, 2, 3. If I fill these with zeros here, it'll be 5300, and that's my answer. So therefore, 1, 2, 3 means that I multiplied by 1,000. Therefore, my card is times 1,000. Tick that off. So we've used that card. Last question on that slide. So 5.3, and I need to do a calculation that gets me to 0.053. Again, I can see I have to move to the left. So that means I'm looking for a division card. Now let's see how far we need to go. We could also have done it from this one to see I need my decimal to be between 5 and 3. So 1, 2. So that means I need to divide by a number with 2 zeros in it, which is 100. So let's go 1, 2. And my decimal is now here, so this will now be 0.053, which means I had to use my card division by 100. Beautiful. So now I would have scored 2 marks. Well done. Now we go for powers of 10, where we are multiplying and dividing by powers of 10 in another way. So we're told what are the answers to the following calculations? I'm multiplying 536 by 1,000. So that means I have 1,000 lots of 536. We know when we're multiplying by powers of 10 and it's a whole number, shortcut, we could simply add the number of zeros along with the number that we have already. So 536 times 1,000, we're just going to be equal to 536 and then add our 3 zeros on. So this is 536,000. Check that off, move to the next question. So we just talked about if I'm multiplying, I'm going to the right if I'm doing decimals, and if I'm dividing, I've got to move to the left based on the place value of my multiplier. So 849, I'm dividing by 100. I'm going to move my place values 2 digits to the left. Remember, the decimal point doesn't move at all. It is the place values of the digit that are getting smaller. So every whole number has a decimal at the end. So I'm just going to put my decimal at the end. And now I need to move 2 positions to the left. So 1, 2. My decimal will now be between 8 and 4. So it's 8.49. Beautiful. And we check that off. So we just reason through, am I multiplying or dividing? And that will tell me left or right. So next question, we are multiplying by 10. So say with me, multiply right, divide left when we are working with our decimals. So 5, 2, so 52.36, multiply by 10, I need to put my place values are getting one, my digits will get 1 position, 1 place value larger. So I'm going to go 1 position to the right. So my answer would be 523.6, 523.6. Beautiful. And we can always check back to see if I move 1 place backwards, do I have the original question? Now I go for question 4. Same principle apply, but now I'm dividing by 1,000. So again, my digit is going to be 1,000 times smaller. So multiply right, divide left. So I'm going 3 spaces to the left. So 1, 2, 3. My decimal point will now be here. So let's just put fillers here. So it'll be 0.00082. And we check that off. We can simply go 1, 2, 3 spaces and see, do I get back my point where it was in the question? And the answer is yes. Beautiful. So we go to question number 5. Now we have 290 and we're multiplying by 0.1. Importantly, 0.1 is the same as 1/10. So 290 multiplied by 0.1 is the same as 290 divided by 10. So therefore, I'm going 1 position backwards, multiply right, divide left. So now I have 29. Beautiful. So now we go for the last question in that section where we are multiplying 387 times by 0.01. So if multiplying by 0.1 is the same as dividing by 10, let's write 0.01 would be what? 1/100. Beautiful. Make sure that you're taking note of that. Therefore, it's the same as doing 387 divided by 100. So we're going 1, 2 spaces backwards. So my answer is 3.87. Absolutely brilliant. Yes, you're becoming brilliant by numbers. Okay, so we go on to another power of 10, but now we're going to look at our index form. So we're asked to fill the empty boxes. A is 7,000, and 7,000 is equal to 7 times 10 to the power of something. So let's write in terms of 7 multiplied by 1,000 would be 7,000. So 1,000 in terms of an indices, 1, 2, 3 zeros here. So in the box, I need a 3. Fantastic. Next question. These ones can be tricky for the one where we've got 8 in this example. 8 times by 10 to the power of something that still gives 8. A misconception here is everyone will think that the answer is 1. But that's not true. If the answer was 1, it will be 8 times 10, which would be 80. But we need 8. And so therefore, we need the 0 power. So any number or value raised to the power of 0 is always equal to 1. So if I had 8 to the power of 0, the answer is 1. So 10 to the power of 0 is 1. Therefore, 8 times by 1 is how we would have had 8. Brilliant. Next question, we've got 0.005, and we need to have that as 5 times 10 to the power of a number. Now remember, whenever we have decimals, we will have a negative power. So again, we need to see what would I need to multiply this by to get to 5. So let's go. 1, 2, 3. So clearly we are multiplying by 1,000. However, because we are moving to the right with this decimal, the power would be negative. Remember, decimals will have a negative indices. So 1, 2, 1, 2, 3. So this would be to the power of negative 3. Just going to write it outside the box again, just for clarity. So to the power of negative 3. Okay. So next, we go on to another multiplication. This time, we're given our multiplication by a power as well. So 0.019 is being multiplied by 10 to the power of 3. Good practice, write what 10 to the power of 3 is as an ordinary number. So 10 to the power of 3 means 10 times 10 times 10, which is equal to 1,000. Fantastic. So therefore, I need to move my place values of my digits will be moving 3 spaces. So let's go. So 0.019, and we are multiplying, which means we're going to the right. So 3 spaces to the right, 1, 2, 3. So now my answer is just 19. Beautiful. Next, we are doing 364 divided by 0.01. So again, if we check this out, 364 divided by 0.01. So 0.01 as a power, this is going to be basically 10 to the power of negative 2. So 1, 2. But again, it is a decimal. So clearly, we're going to need to, I'm going to either write it as a fraction, or we could just keep it as it is, but I think writing it as a fraction would help you better. So let's do it as a fraction. So it'll be 3, so this is division, 3, 6, 4, and then we are dividing by 1/100. So remember the laws that governs fractions. Say we are to keep the first part of the fraction, change, and then we're going to flip. So basically, what we're really doing is multiplying by 100. So the answer then is 364. We could just add the 2 zeros at the end. So it's 36,400. Beautiful. We go to the next question, which is a little bit similar as well. So, but this time we're given 47.5 times 10 to the power of minus 2. So remember, we just converted 0.01 to power of 10, which is 10 to the power of minus 2. So we know essentially this is the same, but this time this is multiplication. So 47.5 multiplied by, let's put 100. Remember, multiplying by 100 is the same as dividing by 100. So 47.5, we are going 2 spaces to the left. So 1, 2. And so our decimal is now before the 4. So 0.475, and that is our answer. Very beautiful. Okay, so now we are going on to estimations and significant figures. We're asked here to estimate the answer to 8.62 plus 22.1 divided by 5.23, and to give your answer to 1 significant figures. Now, whenever a question asks us to estimate, we round all digits in the question to 1 significant figure first of all. So let's go. 8.62, so this is the symbol for approximation. 8.62, first significant figure is 8. We check on the digit behind to see should I round up or down. So I need to round up, so this is approximately 9 to 1 significant figure. 22.1 is approximately, check the first digit, look on the one behind. We have to round down to 20. So this is approximately 20. 5.23, one significant figure is, the first significant figure is 5. Digit behind is a 2, so round down. So now this is just 5. Now that we've estimated all our numbers to one significant figure, we're going to use our new values. So essentially, we're doing 9 plus 20 divided by 5. 9 add 20 is 29. 29 divided by 5. Let's use the bus stop. 29, 5. So 5 goes into 29, can't go into 2, so into 29. So 5 times 5 is 25, and remainder is 4. 5 into 4, we can't, we put a point, add a 0. 5 into 40 goes 8 times. So we have 5.8. But remember, guys, we were told to give our answer to one significant figure. So 5.8, we check first digit. Digit behind, we need to round up. So approximately 6 as a whole number, significant figure. Absolutely brilliant. So now we are asked to estimate the answer to 28.6 times 24.4 divided by 5.67 times 4.02. So again, 28.6. Let me just tidy up my 8 quickly. So 28.6 is approximately, first digit is a 2. Check the one behind, I must round up, so this is approximately 30. Then 24.4, approximately, check the first digit. Digit behind is 4, round down, so 20. Then I've got 5.67, approximately, check the first digit is a 5. 6 after, rounding up to 6. Then 4.02, first digit is a 4. Digit behind is 0, so this is 4. Now we're going to substitute them back into the question. So 30 times by 20 divided by 6 times by 4. Now, guys, the easiest way to do this is to just divide 30 by 6 straight away and 20 by 4 to simplify it. So 30 divided by 6 is 5. And then 20 divided by 4 is also 5. 5 times 5 is 25. So as an estimate, it is approximately 25. Beautiful. Now we go for inequalities. We're asked here to use the symbols that were given to write the correct symbol in each box to make the statements true. So we got 11 times by 12 and 15 times by 10. We're comparing them. We've got to do the calculation. This is where our timetable come in. So 11 times by 12 is 132. 15 times by 10 is 150. Remember, the open mouth of the arrow always turns to the greater number. As we always say, the shark loves to eat the bigger fish. So 120 is greater, so therefore open mouth turn to, so 132 is less than 150. Take that off. Now we've got 90 divided by 30, which is a common mistake, guys, is for people to think 90 divided by 30 is still 30. Remember, 90 divided by 30 is 3. Easy way not to get this wrong is to divide by 10 first. So if I cancel my zeros off there, 9 divided by 3 is 3. So same principle apply for 60 divided by 20. The answer is also 3. So here, both of them have the same, so this is equal. Check that off. Now we've got 120 divided by 4. So 120, 12 divided by 4 is 3. and 0 divided by 4 is still 0, so 30. Then we need to do 160 divided by 8. So we're going to do 16 divided by 8 first, which is 2, and 0 divided by 8 is 0. So 30 is being compared with 20. 30 greater, shark loves the bigger fish, open mouth to 30. Beautiful. Now we've got 30 times by 8 is compared to 100 times by 10. So 8 times 3 is 24. So 30 times by 8 has to be 240. So 100 times by 10 is 1,000. So again, 1,000 is greater. Open mouth turns to 1,000. Spot on. Beautiful. Now, another set of inequalities, but this time we have to do some conversion of our metric units. So write the correct symbol in each box to make each statement correct. We've got 2 kilograms, and we want to know, is that greater than or less than 1,800 grams? So I'm going to convert my kilograms to grams. So 1,000 grams is equal to 1 kilogram. Therefore, 2 times 1,000 will make me have 2,000 grams. So 2,000 is being compared to 1,800, open mouth to the greater number. Beautiful. We go 450 centimeters compared to 5 meters. Again, we need to convert. This time it's better to convert our meters to centimeter. So 100 centimeters is equal to 1 meter. So I'm converting from meters to centimeter. So I'm getting smaller, so I need to multiply. So look at this, guys. This will change your game. If you're not sure if I'm multiplying or dividing, look at this. Open arms, large. So if I'm doing a small number and I am going to be converting it to a large number, I need to, so small to large, your hands end in a division bar. I need to divide. Large to small, my hand ends in a cross, which is the multiplication sign. So large to small unit, multiply. Small to large, your hand end in the division bar, so I need to divide. So I'm going from the large number here to the small one, so I need to do 5 times by 100, which is 500. So I'm comparing 450 centimeters to 500 centimeters, and open mouth turn to 500. Absolutely brilliant. So now I've got 30 minutes being compared to 1800 seconds. So again, we need to convert our minutes to seconds to make it easier. So therefore, we know 60 seconds make a minute. So what we simply need to do, you can use your calculator if you want to, but we should still be able to do this. We know 60 seconds make a minute. So again, we need to do 30 times by 60. So we could do 3 times by 6, which is 18. And then we've got 2 zeros there, so it's 18. What do you notice? Both of them are actually exactly the same. So we put our equal in. Beautiful. I hope that you're paying attention and that you're not just watching, but you're actually writing the question down, or maybe you've printed the worksheet. You need to make sure that you work along. Beautiful. So we are going to go to another question, but have you liked the video yet, guys? Make sure you give it a thumbs up. Make sure you leave me a comment. Let me know how useful this is for you. And also make sure that you hype the video. Lots of people don't know that you can hype a video to put it in the further up in the YouTube algorithm so other people know about it as well and get the help that they need. So guys, where your like button is, if you swipe across a little bit, you will see a button called hype. Help me to get this video to as many users as possible. So now we go for some inequalities with decimals, negative numbers, and fractions as well. So fill in the boxes with either less than, greater than, or equal. So the first question, we have 5.9 being compared with 5.90. Guys, we will not be caught out at all. We know that the 0 at the end of 90 does not change the value at all. So we're sure that that one is equal. So we put that in. Next, similarly to the question we did before, another opportunity just to answer this question, comparing our centimeters with our meter. So we've got 3.4 centimeters being compared with 34 meters. So what best way to do this one is to convert our centimeters to meters, since we've got our centimeters in a decimal. So again, we know 100 centimeter is equal to 1 meter. So again, we are going from the small unit to the large unit. So small to large, we should divide. So I'm going to do 3.4 divided by 100. So we go back 1, 2. So this is 0.34. And now it is in meters. We can see that 34 meters is larger. So open mouth turns to 34. We could also have converted the other way around, but the answer is, however, correct. Now, this one can catch you out if you forget one main principle. So, minus 313 is being compared with minus 331. Guys, for the negative numbers, remember, the larger the negative number, the smaller the value, because it would be furthest away from 0. The closer we are to 0, it is the greater the value. So therefore, the larger number would be negative 313. So the smaller the negative number, the greater the value. Next, we go for a negative 2.15 being compared with negative 2.1. So don't be caught out now. Remember, negative 2.15, it's a bigger number. Therefore, the bigger the negative value, the bigger the negative number, the smaller the value. So the greater one is negative 2.1. Open mouth turns to that number. Now, we are asked to fill in the boxes with the same symbols, but now we've got a fraction and we also have a decimal. So what we need to do, remember, we cannot compare fractions or decimals unless they are in the same form. So good principle here is to rewrite our 0.4 as a fraction as well, easier way. So this is 4, place value is tenths, so 4 tenths. Now, denominators are not the same, but I can scale this one up to 20 as well by multiplying by 2. So times by 2, times by 2. 4 times 2 is 8 and 10 times 2 is 20. So we're comparing 7 twentieths with 8 twentieths, and 8 twentieths is larger. Open mouth turns to that one. Same principle applies. 0.22 is being compared to 6 25ths. So again, easier way to do this one is to change 22. 22 is largest digit here. So this one, hundredths place, so 22 hundredths. I now need to get 6 25ths with a denominator of 100 as well. So I need to multiply 25 by 4 and also 6 by 4. 6 times 4 is 24. 25 times 4 is 100. So I'm comparing 24 hundredths with 22 hundredths, and 24 is the winner. So open mouth turns to 24 again. Comparison, negative 5 with negative 19. The smaller the negative number, the greater the value. So negative 5 is closer to 0, which is closer to the positive side of my number line. Open mouth turn to negative 5. So now I've got negative 3/5 being compared with negative 18 30ths. So again, I could simplify 18/30 negative. So I could simplify this. It will be negative. Common factor here is 6. So 18 divided by 6 is 3. And 30 divided by 6 is 5. So guys, both of them are actually equal to each other. So we put our equal sign in and we're ready to go on. Now we are looking at directed numbers, which still has to do with numbers on our number line. We follow the direction of the numbers. So look at these number cards. So these ones, you've got to play with your numbers, trials and errors to see which one should go together. So we look at our cards here. We're asked to choose any two of the number cards that add to 2. So we need to get to positive 2. We can see here we don't have 1 plus 1, so that cannot be. But we've got a minus 3, we've got a minus 3, we've got a positive 3, and we've got a minus 1 there. So we're looking, so we could do a positive 3 and a minus 1. So 3 plus minus 1 is the same as 3, take away 1, and that gets us to 2. We tick that off. Next question asks us to choose any 3 of the number cards that add to negative 5. We look here, we can see we don't have negative 2 and negative 3 because that would be negative 5. So therefore, we're going to have to play along with some other numbers. And you could try this before looking at my answer. So I can see here that if I use negative 7 and negative 1, that gets me to negative 8. So now I need to go to minus 5. So I need to get a positive 3. So if I put a positive 3, so let's have a look. Negative 7, negative 1, positive 3. Negative 7, negative 1 is negative 8. Negative 8 plus 3 will get me negative 5. So this is I owe 8, I pay 3, I will owe 5. So that works off. The next question says, choose any 4 of the number cards to add to 0. Guys, we look here. We can see there is no zeros there. So the only thought that should come to my mind, I know if I have a positive number and a negative number of the same magnitude, that cancels to 0. What that means, for example, a negative 2 and a positive 2 cancels to 0. So since I need 4 numbers to get to 0, that means I need to look for pet numbers that have a positive and a negative value. So we could use minus 7 and positive 7. That still is 0. I could then use minus 5 and a positive 5. So these two will be 0 and these two will be 0. So all of the expression will be equal to 0. Beautiful. You got to reason your way through it, guys. So now, directed number again, we are looking at temperatures, application to everyday life. So write these temperatures in order, starting with the coolest. We got minus 3, we got 0, we got 6, and we got minus 9. Coldest, warmest. Guys, we know that the closer we are to 0, the warmer we are. This is the UK, guys. We know when it's minus 7, everybody says, oh my days, today is going to be such a cold day. So we know that when we got a minus 9 has to be the coldest. So minus 9, and then when we wake up and we see our temperature is minus 3, we know we're getting closer to 0, which is the warmer days. And so when we get to 0, we know kind of a bit neutral now. And then 6 would then be where we say, oh yes, seems like spring is about to come. Beautiful. We go to the next question. A sequence of numbers decreases by 3 each time. That was highlighted for us there. Write the missing numbers in the sequence below. You can use the number line on the right to help you. So we took away 3 from 7 to get to 4. We now need to do 4 take away 3 as well. And 4 take away 3 is 1. So that's 1. We then need to do 1 take away 3. Remember, common mistake here is where people put 2. No, guys, we're taking a small number from a large number. So 1 minus 3 is minus 2. You could also use the number line. You're at 1, you're going 1, 2, 3 spaces. That will be at -2. So now we put -2 in our box. We need to do -2, -3 again. You could either think about owing somebody £2 and another £3. I owe £5 altogether. Or I could start at -2 and keep going down 1, 2, 3. Either way, I would get to the correct answer. Beautiful. Next, we are doing directed numbers. Now we're multiplying and dividing directed numbers. So answer each of the following multiplication. So we do multiplication first. The first one says 2 times by -3. Now guys, think about a number party happening in math land. When everyone has a partner, every negative has a partner, every negative is happy. Happy means a positive number. But in multiplication and division, if negatives do not have a partner, then the answer is going to be negative because everyone is going to be sad. So, in the first multiplication, 2 times -3, this negative doesn't have a partner. So the answer is going to be negative. Everyone is going to be sad. So 2 times -3 is -6. Again, we're multiplying in the second one, -7 times -2. These two negatives are partners, so everyone is happy. So -2 times -7 is +14. We don't have to put the plus, but I'm just putting it there for emphasis. So next we go, -5 times -6 times 2. Again, we check. Do the negatives have a partner? Yes, they do. So everybody is going to be positive. So -5 times -6 is +30 times by 2 is +60. Next, I go for -4 times -3 times -5. I check. Do they have a partner? -4 and -3 are partners, but -5 is left alone. Everyone is now going to be negative. We're sorry for him. He doesn't have a partner. So we multiply, but we know our answer will be negative. So -4 times -3 is +12. +12 times -5 is -60. Beautiful. Okay, so now we are going to go for division. Guys, the same principle applies for division as well. If the negatives don't have a partner, the answer is negative. If they have a partner, the answer is positive. So these two don't have a partner. 72 divided by -8, we know the answer will be negative. So 72 divided by 8 is equal to, sorry guys, 9. So 8 times 9 is 72, so it's -9. Beautiful. Now we go for -28 divided by -4. Again, they are partners. Two negatives make a partner pair. So 28 divided by 4, or -28 divided by -4 is +7. We check those off. Two negatives again in -49 and -7. Two negatives make a partner. It's going to be positive. So that would give us +7 as well. And then 100 is positive, -4, no partner for the negative. The answer will be negative. So 100 divided by -4 is -25. I know I've just helped somebody not to make those same mistakes that they used to make with their division and multiplication of their negative numbers. Beautiful. So now we go to the number line. The number line below goes up in equal steps, which is highlighted for us. We are asked to fill in the missing numbers, so we don't know the first two at all. But we got 3, 7, 11, and 15. So clearly we are working backwards. So we can see going forward from here, we are adding 4. Adding 4 each time. 4 plus 3 is 7, and so on. So I'm working backwards now because I need to go to the beginning of the number line. So instead, I've got to do 3 take away 4. Again, guys, remember, large number take away from a small number. ends with a negative. So 3 minus 4 is minus 1. I then need to do minus 1 minus 4. I owe 1, I owe 4, I owe 5 altogether. So the answer is minus 5 and minus 1. Beautiful. Now I go to another number line where I'm now asked, we're told that the diagram shows a part of a number line. What number is the arrow pointing to? Now, guys, the best way to go about this is to look at the distance between the two numbers given here. So between 5 and 6 is 1 unit. So 1 unit. And now we need to share that in, let's see how many parts. So from 5 to 6, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 parts. So to know what each single part is, I need to do the 1 divided by 10. And guess what? We just did some divisions by 10. So we know we are decreasing place value, 1 place value backwards. So from here, 1 digit behind will make us have 0.1. That means each small line is 0.1. So the place we're asked to identify, 5, 5.1, 5.2. There we go. And it doesn't matter how many sections your number line is divided into, you need to do the same principle, okay? So now it says, now draw an arrow on the number line above to show the number that is less than 1.2. Sorry, that is 1.2 less than 7. So subtraction. So part B, we are doing 7, let's put 7.0, take away 1.2 to see the number they want us to do. So we cannot take 2 from 0, so take 1 from 7 there, even 6. So 10 take away 2, that's 8. And 6 take away 1, that's 5. So we really want to do 5.8. We knew that this was 5.2, so 5.3, 4, 5, 6, 7, 8. So I'm putting my arrow here. That is my arrow nice and bright. So I can also just put 5.8 here. Beautiful. Next question, part C, say work out the answer to 6.7 minus 0.8. Didn't ask us to draw it on the number line, just ask us to work it out. So 6.7 and we're taking away 0.8. Nice and simple question there. So 7 take away 8, we cannot do that. So we're going to take 1 from the units column. So now we're doing 17 take away 8. We know 8 add 8 is 16 and we need 1 more to get to 17. So that's 9. And then 5 take away 0 is still 5. So the answer is 5.9. Absolutely brilliant. Now we go for ordering decimals. So we're asked to write numbers in order of size starting with the smallest. We got 1.9, 0.96, 1.253, and 0.328. A good practice, guys, is to order the decimals and line up the decimal points and then compare the digits. So I know that the ones with 0 will be the smallest, but let's line them up first. So 0.96, 0.328, 1.9, and 1.253. So we know we cannot compare the zeros at the beginning because they are the same. We go to the next column, which is comparing the 9 and the 3. 3 is the smallest, so we know this one, 0.328 is the smallest, so we put that down, 0.328. Therefore, 0.96 is the second smallest. So comparing the next two, we cannot compare the ones, they're the same. We go to the next column. So 2 is smaller than 9. So 1.253 is the smaller one, and then 1.9. I know people will say, I think I can do it without ordering them, but guys, under pressure in an exam, you can make those simple mistakes, so to avoid them, this is what we need to do. Next question, which number is closest to 1? 0, put a ring around it. 1.4. So when we do them, we're going to find out how far they are from 1, and then we make a decision. So 1.4 is 0.4 away. Would you agree? If we're getting to 1, then if we take off the 0.4, we will have 1. So it's 0.4 away. 1.35 is 0.35 away from 1. Then 0 is 1 away from 1. See that? A whole 1. Then 1.65 is 0.65 away from 1. So that means the smallest one, if we compare these, then 0.35 is the smallest of the numbers. So the answer is 1.35. You see, it's that clear, logical thought that brings my answer to perfection. Absolutely fantastic. Now we go for multiplying numbers. So we're asked here to write in the missing digit. So we're asked box 7 times by 9 is equal to 333. So guys, we know if we multiply two numbers together and we get an answer, the answer divided by one of the numbers will give us the other number as well. So I can do 333 divided by 9 and see what we get, and then we will know what should go in the box. So 9 into 3, I can't do that. So 9 into 33. So 9 on my 9 times table, if I go 4 times 9 is 36, that's too much. So we need to go 1 down. So 9 times 3 is 27. So 27, 28, 29, 30, 31, 32, 33. That's 6, guys. So we put that here. Don't be afraid to count your fingers, count your toes if you got to, but we got to get the right answer. So now we need to see 9 into 63 goes 7 times. So clearly our box here is missing a 3. So it's 37 times by 9. Beautiful. Now we go for this calculation. So we're told that 4 box multiplied by box 6 gives us this answer. So I know I have to think about numbers that when I multiply them by 6, the answer is 6. So it could be 1, it could be 6, because 6 times 6 is 36. So let's see. It could also have been 4. So it couldn't be 4 because 6 times 4 is 24. So it's either 1 or 6. But let's look at what we got here. So if I put 6 here, I would get 6 times 6, 36. Then I would have to bring 3 to the other column. 6 times 4 is 24. We would have passed this 24, so it can't be 6 at all. So it has to be 1. 6 times 1 is 6. 6 times 4 is 24. So we know that 1 is correct for that line. Now we need to see what did I multiply by. So first of all, a number times 1 must give me 2. The only number times 1 that can give me 2 is 2 itself. So let's go. 2 times 1 is 2, and 2 times 4 is 8. We can see that it's 1 and 2 that's missing. We go on to a harder one, but the same principle apply. So we're asked to write the missing numbers again. So we need a number at the end that multiply by 7 to give us a number ending with 5. Are you thinking what I'm thinking? That it has to be a 5, because 5 times 7 will give us 35. Can you think of any other number times 7 that ends with a 5? I can't, so this has to be 5. So let's go and check this across now. So 5 times 7 is 35. We would have brought 3 to this column. 5 times 1 is 5 plus 3, that's 8. 5 times 3 is 15. But now I need to get to 11. So let's go. 5 times 3 is 15. I would have to bring 1 here. So 5 times something plus 1 should make 11. And that has to be 2, since 5 times 2 is 10 plus 1 gives us this 11. Absolutely brilliant. Now we go multiplication grid this time, and then we also have 2 decimals to multiply. So we're asked to write the missing numbers in these multiplication grid. So whatever we put in the first row and what we put in the column, when we multiply the digits, we should get 24. And when we multiply the digits as well, we should get 15. And in the other way, when we multiply them, we should get 16 and also 10. So I need factors of 24 and 16 and factors of 15 and 10. So factors of 16 and 24, it could be 2, we could have 4, we could have 8, so and so on. So this one, we would have to do some trials and some errors. But in the end, we should get these numbers. So also factors of 15 and 10, 5 and 10 itself, or 5 and 1. Okay, so let's see. We need 2 numbers multiplying together that will give us 24. So I could see that if I put 3 here and 8 here, then 8 times 3 is 24. And I need something times by 8 that gets me 16, but it should also be able to do that number times by the 1 in the right hand to get me 10. So if I put 2 here, I can see 2 times 8 is 16. So now how do I get from 2 to 10? That's 5. And that also gets me from 3 times by 5 is 15 as well. So for these ones, once you know your factors, you should be able to figure it out by trial and error. Now we go for this question. We are multiplying 57.3 times by 21. Sorry, times by 2.1. Okay, so then guys, what I need to do here is to see how many decimal places are in both sides. So 1 decimal place is in this one, and also 1 decimal place in this one. So I know my answer should have 2 decimal places, which means that if it's 2 decimal places, when I multiply, I'm going to multiply them as whole numbers, and then I will have to divide 2 decimal places indicates I will need to divide my whole number answer by 100 to get my 2 decimal places. So let's do our multiplication. 1 times 3 is 3. 7 times 1 is 7. So we know 1 times 5, 5. 0 for my placeholder. 2 times 3, that's 6. 2 times by 7, that's 14. Take 1 to the next column. 2 times 5 is 10 plus 1, 11. Now I add them together. So 3, 7 plus 6 is 13. Bring 1 to the next column. 5 plus 4 is 9 plus 1 is 10. 1 to the next column. 1 plus 1 is 2, and I get 1. Remember, I now need to divide this by 100. So 2 spaces to the left. 1, 2. So the answer is 120.33. I bet you didn't know it was that simple. Oh, yes, it is, guys. It is the principle that works for you. Beautiful. Okay, so now we are going to move on to division of decimals. Have you liked the video? Yes, come on, guys. Hit that thumbs up for me and help me to get this channel to grow. Thank you for doing that. So now we go for dividing with decimals. So divide 864 by 0.4. So 864 divided by 0.4. So guys, the best way to approach this is to convert our decimal number that we're dividing by to a whole number. We can do that by multiplying by whatever power of 10 it takes to get it to a whole number. We can see here, if we multiply by 10, this will now become 4. Remember, we've got to also do it to the other side as well. So multiplying by 10 here gives us 8,640. This is just like adding a 0 on if we think of it as a shortcut. So now we're going to use our bus stop method to do our division to ensure that we are accurate. So 4. So 4 into 8 goes 2 times. 4 into 6 goes once. 4, remainder 2. So 4 into 24 goes 6 times, and 4 into 0 goes 0 times. So the answer is 2,160. Absolutely fantastic. Now we're asked to work out 525 divided by 0.7. Again, same principle apply. We're multiplying by 10 both sides so that we get our whole number to divide by. So this would be 5,250, and we're dividing that by 7. So again, set up our bus stop, 75250. So 7 into 5, we can't do that, so we go to 7 into 50. So closest number to 52 on our 7 timetable is 7. Guys, make sure you study and know your timetable always. People who know their timetable have an advantage on the calculator, on the non-calculator paper. Make sure you need to, when you're doing your Sparks Maths or whatever your homework platform is, you must go to the multiplication table side to get your skills up. So 7 times 7 is 49. 9, 10, 11, 12. So that's remainder 3. So now we need to go 7 times by what makes 35, or 7 into 35 goes 5 times. 7 times 5 is 35. So now we just need to do 7 into 0, which is 0. So our answer is 750, and we tick that off. Beautiful. So we move on. Now we are on to substitution. We're given that f is equal to 7 and g is equal to 5. We're asked to work out the value of 3f plus 2g. So 3f plus 2g. So you must write out what you're given and substitute directly into that. So 3 is being multiplied. Remember, 3f means 3 times f, so I'm multiplying. So f is 7, so I'm putting that for 7 plus 2 bracket, g is 5. So 3 times 7 is 21 plus 5 times 2 is 10. 21 plus 10 gives me 31. So I check that off. Oops. Sorry guys, just give me 1 second. Okay. Now we move to the next question where we are given v is equal to u plus at. So u is equal to 3, a is equal to 10, and t is equal to 6. We're asked to work out the value of v. So let's go. V equal to u plus at. So we know u is 3, so 3 add a is 10. So 10, put them in bracket, t is 6. So that would be equal to 3 plus 10 times 6 is 60. Add together is 63, and we tick that off. Well done. Next one, x is 4, y is 6. Work out the value of 3x minus y. So 3x minus y. 3 times by x, which is 4, and we're taking away y, which is 6. So let's put that in brackets so we keep that rhythm. So 3 times 4 is 12. 12 take away 6, that's equal to 6, and we check that off. Now we're doing q is equal to 5p plus 3r. So 5p plus 3r, and that's equal to q. So that's 5 times by p, which is 6, plus 3 times by r is minus 4. See why it's good to put it in bracket? So 5 times by 6 is 30, and positive 3 times minus 4, remember, negative don't have a partner, the answer will be negative. So that's negative 12. 30 take away 12 gives us 18. So remember, guys, use your column method to make sure that you're accurate. Don't just think it, you must also ink it. That's it. Okay, now we move on to function machines. So here is a function machine. Input, whatever we put in, input will always be divided by 4, and then we subtract 1 to get the output. We're asked to A, work out the output when the input is 24. So we're going to substitute our input for 24. So 24 divided by 4, take away 1 will give us our output. BIDMAS tells us to divide first. So 24 divided by 4 is 6. 6 minus 1 gives us 5. So we check that off. Next, we go for part B. So part B tells us to work out the output when the input is 42. So again, input is 42 divided by 4 minus 1. BIDMAS says divide. But let's set this one up. Sorry, this way. So 4. So 4 into 4 goes once. 4 into 2, 0 times. We put a point and add a 0 in. So 4 into 20 goes 5. So we have 10.5, take away 1, and that's equal to 9.5. And we check that off. Now we go for part C. This time we're asked to work out the input when the output is 17. So we don't know the input this time. Let's call that x. But we know x divided by 4, take away 1, should be equal to the output, which is 17. So now we will have to solve this equation. So we're going to look at what we have in the question, what operation we currently have, and what we need to do. So we have a minus 1. We're going to H is for have and D is for do. So we've got a minus 1 and we are going to need to do a positive 1, which is the opposite. We also have a division by 4. So we're going to need to multiply by 4. So first, let's add 1 to both sides. We get that x quarters is equal to 17 plus 1 is 18. Check that off. We've done that one. Now we need to multiply by 4. So I'm just going to write this here so it's nice and clear. That's a rhyme right there. So we need to multiply both sides by 4, or we could just consider multiplying 18 by 4. So this cancels out. We got x left. 18 times by 4, guys. Do not take a check. If you don't have a calculator, use your column method. So 4 times 8 is 32. Bring my 2 to the next column. I've got 4 times 1 is 4 plus 3 is 7. So the answer is 72. Absolutely brilliant. So we've done our function machine and we carry on to algebra. We are asked to link the algebra to the correct description. So one has been done for you. Now, guys, it's always a good thing to know the language, the mathematical language, the meaning of words actually help us to break our questions down when we get them. So we got P equal to 3x plus 4y. That one was matched for us as a formula. Now we got 3x here plus 6. So 3x plus 6, these 3 lines means identity. Identity. And that means what we got on one side will also be on the other. So let's see if that's true. If we expand the bracket, x times by 3 is 3x and 3 times by 2 is 6. Can you see? It's the same thing. So that means they are identical. So that matches with identity. I've pre-drawn that in so that it is very nice and neat in your exam, guys. Make your work be presentable. So you take a ruler and you fill that in. So 3x plus 2 equal to 14. Now equal to 14, equation. So that one is an equation. Match that in. 3x plus 2, expression. That one is an expression because I cannot find an actual answer. So let's say you don't know my age, which you don't, and I know that you are, let's say, 10 years younger. You cannot tell what is your age until you know mine. You can only express it. So let my age be x X take away 10 will be your age. So that's an expression. A variable term and a number term makes an expression. No equal sign. So 3x, so we've done inequalities just now, and we matched inequalities. So once we have a less than or greater than or less than or greater than or equal to sign, then we know we've got an inequality. Make sure you know your expression different from your equation. Use the equal to know that the one, sorry, with an equal sign is my equation. So we carry on our matching activities. Match each statement to the correct expression. A very good time to practice your expressions now. The first one has been done for you. So the first one was add 2 to A. Now, people always get this wrong because they feel like A plus 2 is the same as 2 plus A. No, it's not. So A plus 2 means I'm adding 2 to A. So I started with A, then add 2. 2 plus A means that I'm adding A to 2. That means I started with 2. So we need to focus on what did we start with, and that will help us to avoid inaccuracy. So subtract 2 from A. This means I start with A and take away 2. So that's be A minus 2. And we match that one. Multiply A by 2. A times 2 is 2A. And the misconception here is that people think they will have A squared. Not true at all. 2 lots of A is 2A. Divide A by 2. So this one can be written as A over 2. Not 2 over A. We are dividing A by 2 and not 2 by A. So that one matches the last one there. Multiply A by itself. So A times A is A squared. So we always mix up multiplying A by 2 with A by itself. Remember, A times 2 is 2 lots of A, 2A. Now we go for match each section equivalent to the algebraic expression. Write the missing statement. So you got a statement to write as well, which is really good for you to practice. So 5 more than Y. Question, what did I start with? I started with Y and then have 5 more than that. So Y add 5. So I've put letters here so that I could just put the letters in the one. So 5 more than Y is Y plus 5. We search for that and I'm going to put the letter beside it. So Y plus 5, this one then is A. So Y less than 5. Where did I start? I started with 5 and then I've got Y less than that. So it's minus Y. So 5 minus Y is then B. Y multiplied by 5. So Y times 5 is 5Y. So 5Y is here, so that's C. Okay. Y divided by 5. So start with Y, divide it by 5. Y over 5 is D. Double Y is the same as multiplying by Y by 2. So that is 2Y. So we look for 2Y. It's all the way to the top here. So this is E. Then we have 2 left and they want us to write the words. So Y minus 5. So it's 5 less than Y, the opposite of the one here. So 5 less than Y. Beautiful. So next, for the last one, we've got Y squared. So that's similar to the one we did here. Multiply A by itself. So multiply Y by itself. And that's our answer. So you see how I break it down? I think, I reason, where do I start? And that is very important. Now we go for simplifying expressions using multiplications and subtraction, divisions, or combinations. Let's go. So simplify A times B times C. When we're multiplying, we're just putting all the letters together, guys. So A, B, C. And do you know your ABC? Yes, you do. So next one, simplify 5P, take away 2P. So this is just like 5 pencils, take away 2 pencils, simply 3 pencils. Sorry, simplify 6H divided by 3. So this is just dividing 6 by 3 and keeping our variable. So this is simply 2H. Simplify 6F, take away F. So F is like having 1F. So 6F, take away 1F is 5F. Beautiful. Next one, we have simplify 7x squared minus 3x plus 3x squared plus 6x. Now, a common mistake is to think that because they have x, they are similar. No, one is x squared and the other is x. So we have to group the x squares together. So 7x squared and positive, keep the sign that's before them. Very important. So this is not just 3x, it's positive 3x squared. And this one is a plus 6x, and this one is a minus. Notice I put my plus first. It's easier to navigate that way. So 7x squared plus 3x squared is 10x squared. And 6x take away 3x is positive 3x. Beautiful. Next section, A times B times 3. We go for our number first. So A times B is AB, but times 3 is 3AB. Now, y times y was y squared. So what is y times y times y? It is equal to y to the power of 3, which we say y cubed. Why is that so? This one has an automatic power of 1, 1, 1. So the laws of indices say we add the power. So 1 plus 1 plus 1 is 3. That's the rationale behind our answer. Simplify 10d divided by d. So d goes into d and d goes into d. We're only left with 10. So 9k squared divided by 3k, number with number. 9 divided by 3 is 3. And k squared divided by k, we could cancel 1k here with 1 from the top, leaving us with k. So we will just have k for the variable term. So that's 3k. Beautiful. Well done, you. So now we go for perimeter and area. The diagram shows a rectangle. Its dimensions are 3a by 5b. We can see that here. We're asked to write simplified expressions for the area and the perimeter of the rectangle. So we know that when it comes to the area of a rectangle, the formula is area equal length times by width. So we need to do 3a times by 5b. So 3 times 5 is 15 and a times b is ab. So my answer is 15ab. Beautiful. The perimeter. So remember, perimeter, the prefix peri means around and meter means to measure. So perimeter means to measure the distance around. So we know it's a rectangle, so this is also 3a and this is also 5b. So the perimeter will be 5b plus 5b plus 3a plus 3a. I love to go alphabetic, so 3a plus 3a is 6a, and 5b plus 5b is 10b. So 3a plus 3a is 6b, 5b plus 5b, 10b. So the perimeter then is 6a plus 10b. Absolutely fantastic. Now we go on to part B. A different rectangle has an area of 12a squared and a perimeter of 14a. What are the dimensions of this rectangle? So a good practice here is to sketch it. Sketch the rectangle. Now remember, when we add all the way around, it should be 14 for the perimeter. but when I multiply it, it should be 12. So let's look at some factors of 12 that when we multiply them, we get 12. So 1 times 12, 2 times by 6, 3 times by 4. Okay, so those are the factors of 12. But remember, each side, these two sides are the same, and these two sides are also the same. So when we put our numbers there, or our number, or our expression, because it could be a letter and a number together, when we add them around, it should be 14. And when we times length times width, it should be 12a squared. That tells me that each side will have an a there. We are sure about that because only a times a can get us a squared. So let's see. We know it can't be the first one because if we have 1 plus 1 plus 12 plus 12 for the perimeter, that's not going to give us 14. But what if we have 2 plus 2 plus 6 plus 6? Does that give 14 along? 6 plus 6 is equal to 12. 12 plus 2 is equal to 14. And 14 plus 2 is 16. We have passed the perimeter of 14 that we should get. So couldn't be that one. Therefore, it has to be 3 and 4. But to get a squared, we will have 3a and 4a. So let's test the principle now. 3a times 4a. 3 times 4 is 12, and a times a is a squared. So the area checks off. Let's check the perimeter now. 3a and 4a. So 4 plus 4, that's 8. 8 plus 3, that's 11. And 11 plus 3, that's 14. So our answer then, it's a 3a by a 4a rectangle. Give me an imaginary high five. Well done, guys. Okay, so we continue with perimeter and area. The width of a rectangle is x centimeters. The length is 2 centimeters longer than its width. We can see that here, x. So if you had gotten the words and you've got to draw it, that's what you start with x and then add 2 to that for the other side. Find an expression in terms of x, because we'll have to have variables since we don't know the numbers, for the perimeter and the area. So again, perimeter would be equal to, this side is also x, that side is x, add 2. So we need x plus 2 plus another x plus 2. So let's get all our x's together. So 1, 2, 3, 4. So that's 4 x's altogether. And then 2 plus 2, that's 4. So then it will be 4x plus 4 centimeters. Brilliant. Area we know now is equal to length times the width. So be careful with this one. We've got to do length times width. So that's going to be x, but we've got to put this in bracket because we're multiplying x both by x and also by 2. So x add 2. So let's go. X times x gets me x squared, and x times 2 gets me 2x. And then remember, units centimeters squared. Absolutely fantastic. So now we go for a pentagon that is shown. So shown is a pentagon. We got y, x, 2x. Find an expression in terms of x and y for the perimeter of the pentagon. Again, perimeter means we're measuring the distance around. So let's go. X plus 2x plus y plus y. So 2 plus 1 plus 1, that's 4x plus y plus y, 2y. And that's our perimeter there. Beautiful. Expressions with reasoning now. So a teacher has a large pile of cards. An expression for the total number of cards is 6n plus 8. So that's our card here. Part A, the teacher puts the cards in 2 piles. The number of cards in the first pile is 2n plus 3. So that's our first pile. The second pile we don't know, but we can find it. We're asked to write an expression to show the number of cards in the second pile. So guys, we know the total is 6n add 8. So 6n add 8, and we know the first pile have 2n plus 3. So we need to subtract that, but we need to put what we're subtracting in bracket. We could have just done 6n take away 2n. and then do 8 take away 3. But if we're to write it in an order, we need to do this. So 6n plus 8 minus times by 2n is minus 2n, because this is like minus 1. Then minus times by 3 is minus 3. Now we can see we're doing 6n take away 2n and then positive 8 take away 3, which is what you could have just thought in your mind, but you've got to think and ink. So 6n take away 2n is 4n, and 8 take away 3 is positive 5. So the other cards will be 4n add 5. Last question on this expression reasoning question, part B, the teacher puts all the cards together again. Then he uses them to make 2 piles. There are 23 cards in the first pile, and the first pile has n plus 3. Okay, the second cards have 5n plus 5. So it says how many cards are in the second pile? You must show your working. So I know that the first card is equal to 20. The first pile is equal to 23 cards. So I will need to do n plus 3 is equal to 23. If I find n, I can therefore find how many cards is in the second pile. So again, we look what we have in the question, what we need to do. So the operation we've got is a plus 3. We need to do a minus 3 on both sides. So minus 3, minus 3. So n is equal to 20. 23 take away 3 is 20. So now I can work out the other pile. So 5n plus 5. But guess what, guys? We know what n is now. So 5 is being multiplied. Remember, 5n means 5 times n. So multiplied by 20 plus 5. Nice one. 20 times 5 is 100, and 100 plus 5 is 105. We end intelligently. 105 cards. Absolutely brilliant. Guys, I'm so proud of you for investing in yourself. How amazing is that? Beautiful. So we're going to now look at expanding brackets. Okay, so that's what we're going to do. So put in the comment section and let me know, how are you finding this revision session? Make sure that you share it with someone as well. Don't keep it to yourself now. Beautiful. So we're asked to expand the following expressions. First one, 3 bracket x add 4. So remember, we use the term outside the bracket to expand all the terms inside the bracket. So 3 times x gets us 3x, and 3 times 4 gets us 12. Pay attention to signs. Next one, we're doing 5 bracket a minus 2. So again, 5 times a gets us 5a, and 5 times minus 2, remember, 1 negative doesn't have a partner. It's going to be negative. So that's negative 10. Next one, we've got half of 6x plus 8. So multiplying by a half is the same as dividing by 2. So half of 6x is 3x, and half multiplied by 8, half of 8 is 4, and it's positive. Beautiful. Same principle apply for this one, even though it's got 3 terms there. So 3 times by 4x is 12x. 3 times by 5y is 15y. 3 times by negative 2 is negative 6. Again, 1 negative makes it negative. So minus 4 times a half x. So again, it's the same as halving minus 4 here, which is minus 2x. Pay attention now. And negative times a negative will give me a positive, 2 pairs. So it got a pair. So 4 times 3 is 12. So negative 2x plus 12. Beautiful. So we got an expansion now where we have to expand and simplify the following expressions. So we treat each part separately and then collect the like terms. So let's go. 3x add 4. Let's do that part first. 3 times by x is 3x, and 3 times 4 is 12. we got a plus 2 being multiplied by x minus 1. So 2 times x is 2x, and 2 times negative, remember, 1 negative, so it's minus 2. So we need to collect our like terms. So 3x and 2x are like terms, and positive 12 and minus 2. So 3 plus 2 is 5 in x, and 10 will be given from 12 minus 2. So 5x add 10. We check that off. We go to the next question. So 5 bracket a minus 2 minus 3 bracket a plus 1. Again, 5 times a is 5a. 5 times minus, there is minus 10, 1 negative in multiplication. Minus times by a positive is minus, so that's minus 3a. Minus 3 times a, minus 3a. Negative times a positive is a negative, so negative 3 times 1 is negative 3. Notice how I physically collect my like terms, keeping my signs that's before them. So this is positive 5a, negative. So if it works for you, put a box around them so you keep their signs, minus 10 and minus 3. So 5 take away 3 is 2 in a. I owe 10, I owe 3, I owe 13 all together. The language will help you guys. So the next one, we are doing minus 4, 2x minus 3, minus 2, x add 5. So again, negative times a positive is negative 8x here. So minus 4 times 2 is minus 8 in x. Minus and a minus, they will pair together. They're happy. Happy is positive. So 4 times 3 is 12. Minus and a positive, 1 negative. So minus 2 times by x is minus 2x. And negative again times positive, negative 2 times 5, 10. Collect my like terms, minus 8, don't forget, minus 2x, minus 8x, minus 2x, plus 12, minus 10. The signs matter. Directed numbers tell me the direction of my numbers. So I owe 8, I owe 10, sorry, I owe 8. I'm thinking of the answer, guys. I owe 8, I owe 2, I owe 10 in x. Okay, plus 12 take away 10 is positive 2. So there goes my answer. It's that clear, logical thought. Think it and then ink it. Let's go. So this time we're going to do the opposite of expanding brackets, which is factorizing. Factorizing means you're going to put back things in the bracket they may have come from. So when we're expanding, we take them out of the bracket. When we're factorizing, we're putting them back into bracket. And to do that, we do that using common factors. Now, guys, there is a difference between factorizing and factorizing fully. If a question says factorize, you could take out any common factor. But if it says factorize fully, you must take the highest common factor. So I always encourage people to always factorize with the highest common factor. Then you won't make a mistake and forget when you should do it fully. So let's get the highest common factor of, so we need the highest common factor of 4 and 20. And that's 4 itself. But there is no factors with the letters because this one doesn't have a letter. So 4 is the highest common factor. So now we need to go from 4 to 4t. So 4 times t makes 40. So that's what I should get there. How do I get back from 4 to 20? 4 times 5 make 20. We can then do a quick check. 4 times t is 40 and 4 times 5 is 20. So I know for sure I am correct. Beautiful. So let's get the highest common factor of 18 and 63. Again, I need to know my timetables. So I can see here 9 goes into 18 and also into 63. So 9, there is no y on 18, so I can't take a y. It's just 9. So 9 times by 2, how do I get from 9 to 18? Times by 2 plus, how do I get from 9 to 63? So 7 nines make 63. And I also have y. So I need to check. 9 times 2 gets me to 18, and 9 times 7y gets me to 63y. Absolutely fantastical. Now I'm factorizing 18x at 4. Highest common factor is 2. 2 goes into 18 and also into 4. So no x on there, so I've got to just use 2. 2 times what gets me to 18x? 2 times 9, and then I also need x plus 2 times what gets me back to 4? It's 2. So check. 2 times 9x is 18x, and 2 times 2 is 4. I know I am correct. Factorize 18 plus 24m. Highest common factor of 18 and 24 is 6. No m's, so m is not considered. So 6 times by what get me to 18? 3. 6 times by what get me to 24? 4. And I also need m. So 6 bracket 3. So let's check. 6 times 3 is 18. 6 times 4m, 24m. So I know for sure I am correct. Now I go to factorize fully. So guys, I've taught you how to factorize fully from day one. Unless a question says, show different ways this could be factorized, and you could take a smaller factor. But just to avoid errors, always factorize fully. So factorize fully, 5a squared b plus 15ab squared. So highest common factor, let's take it off the numbers first. The highest common factor of 5 and 15 is 5. That goes into both of them. But what about a squared and a? We have to take a since this one only has one a. So we cannot take the a squared because both of them doesn't have an a square. But within this one, a square means a times a. So within this one, I can find an a and a spare, and this one I can find an a. So a is the common factor, and the b will be the same since one b is here, but this one has b squared. We can only take the one that is common to both. So this one will have a b and a b, so we could only take one b to match this one that has one b as well. So the highest common factor goes outside. Let's get from, so now we need to get from 5ab back to 5a squared b. The 5 is already outside. We don't need that. But we got 1a and we needed a squared. So we need another a inside. But the b that was there is already on the outside. We don't need another b at all. So let's check. So 5ab times a, that means the a's will be squared. So that would be 5a squared b. So that's correct. So how do I get from 5 to 15? I need to multiply by 3. Let's check what we got. The a is already on the outside of the bracket, so I don't need to do that. And the b, we only have one b outside, so that means I need another b to get me back to b squared. So 5 times 3 is 15. ab times by b is ab squared. So I'm sure I am correct. Next one, factorize fully, 6x squared y plus 9xy squared. So highest common factor. Highest common factor, 6 and 3. 6 and 9 is 3. I keep thinking my answers out. X squared and x is just going to be x. Y and y squared is just going to be y. So to get from 3 to 6, I need to times by 2. I need another x because I've got x squared when I only have x outside. And the y is already outside the bracket, so I don't need a y. So 3 times 3 gets me back to 9. I've got the x outside and also one y. I need one more y to complete the set. So 3 times 3 is 9. xy times by y is xy squared. So I'm sure I am correct. Next one, factorize fully, 7xy plus 21x. Highest common factor of the numbers is 7, which is the coefficient of the numbers before the letters are called coefficient. So 7 and x is also common, but not y at all. So 7x goes outside. 7x times what gives me 7xy? Only the y is missing. Plus 7 times what make 21? That's 3, but I've got the x already. Don't need an x at all. That's completed. So next one, factorize fully. 8ab squared plus 12a squared b. Highest common factor, let's get the numbers first, of 8 and 12 is 4. Check for a's. A and a squared, I will just have to take a. B squared and b, I will just have to take b. So 4 times what gets me to 8? That's 2. The a is already outside the bracket, but there's only one b outside. I need b squared, so I need another b. Plus 4 times what make 12? 3. A squared I need to get. 1 is outside, so that's a. And then I've got the b already outside. So let's check. So 4 times 2 is 8. AB times b is ab squared. Correct. 4 times 3 is 12. A times a is a squared, and I've got the b as well. So also correct. Absolutely fantastic. Now we go for solving equations. So we kind of preempted our solving equations when we did other questions. So by now, we know we need to check the operation that's in the question and do the opposite. So let's go. So solve x plus 6 equal 25. X plus 6 equal 25. I've got a plus 6, so do. I have a plus 6, I need to do a minus 6. So minus 6 from both sides. X then will be left here since this cancels out. So that cancels out. And then 25 take away 6. So guys, if you know you're not good at calculations, break it down. So if I take 6 from 15, that will leave me with 9. So clearly that's going to be 19. Check that off. Now I go to my other question. So therefore, I'm doing solve d divided by 2 equals 6.5. So d halves is equal to 6.5. In my question, I have a division by 2. I'm going to need to do a multiplication by 2. So times this by 2 and times this by 2. 2 cancels out here, leaving me with d. 6.5 times 2 is the same as doubling 6.5. So double 6 is 12 and double a half is 1. So that's just 13. 12 plus the 1 is 13. Next one, I'm doing m minus 5 is equal to 43. So again, what I have a minus 5. I need to do a plus 5. So plus 5 cancels out, leaving me with m on this side. So 43 plus 5 is 48. Check that off. Now I'm on to the next side where I'm asked to solve 36 divided by y is equal to 9. So that one is easy. You could just do 36 divided by 9, but we're not going to do that. We're going to follow the principles. So what I have in the question, 36 divided by y equal 9. What I've got in the question, I have a division by y. I need to multiply by y first. So times by y times by y. Y's cancel out, leaving me with 36. 9 times by y is 9y. So now I'm multiplying by 9. I need to divide by 9. If the question is a 1 marker, you could just do 36 divided by 9 straight away. So let's go. We now need to divide both sides by 9. 36 divided by 9 is 4, and this will cancel out. So therefore, y is equal to 4. And we can check 36 divided by 4 is 9. Next question, 4a equal 24. Nice and easy. I am multiplying. So 4a means I'm multiplying by 4. I need to divide by 4 on both sides. So 4 divided out itself there, a is equal to 24 divided by 4 is equal to 6. Next, we've got 20 minus m equal 12. So we have to do the opposite of minus m, which is plus m to both sides. So 20, the m's cancels out on this side, 12 plus m. So I need to take away 12 now from both sides. 20 take away 12 is 8. And that cancels out on that side, leaving us with m. So m, therefore, is equal to 8. Again, this one we could have just done m equal to 20 minus 12. But again, when you get to more complex topics as you get older into higher level, you would recognize that you have to show all of your steps depending on the question. So we may as well learn to do it now. Beautiful. So now we go to forming algebraic expressions. We're told that in 1 week, Gina spent X minutes on the internet. Sammy spent 15 minutes less than Gina. Write down an expression for how long Sammy spent on the internet. So let's go. Gina was equal to X. So Sammy was, and we kind of done a few of these in other questions before, but not from words. So Sammy was 15 minutes less than Gina's, and that means it's X take away 15. So we put that on our answer line, and that's in terms of minutes. Beautiful. So now we go to another question where we are doing, sorry guys. So Neil spends 3 times as long on the line, 3 times as long as Gina on the internet. So again, write down an expression for how long Neil spends on the internet. So again, we know Gina was X and Neil is 3 times of that. So 3 times of X is 3X. So Neil spends 3X minutes. Okay, we are ready for the final question on that section. So write down an expression for the total time spent on the internet. So we know total means the add. So Gina is X, so total equal to X for Gina. Sammy was X minus 15. And Neil was 3X. So collect our X's together. X plus X is 2X plus 3X. That's 5X, and we then have minus 15. So our answer is 15X minus 15 minutes. We can only know in terms of a number when we find out for Gina. If we know for Gina, we know for everyone else as well. Beautiful. So just checking here. So 3 times by X, 3 times as long. Beautiful. So 5X minus 15 is indeed correct. Okay, so we need to go on to the next question. We're told that Martin is X years old, so getting a little bit more complex as we go along. Jennifer is 3 years younger than Martin, and Connor is twice as old as Martin. Write an expression for the sum of their ages. So let's go M for Martin, he's X. Jennifer is 3 years younger, so that's X minus 3. And Connor is twice as old as Martin, so Connor is 2 times X, which is 2X. Sum of their ages is going to be, so total again is equal to X plus X minus 3 plus 2X. Collecting our terms together, X plus X is 2X plus 2X again. That's 4X, and we got a minus 3 will be the sum of their ages. Now, Nicola has Y marbles. Sean has 25 marbles. Vicky has 10 marbles. Write down an expression for the total number of marbles they have. So, total again, Nicola is Y plus Sean is 25 plus Vicky is 10. So 25 plus 10 is 35. So it's Y add 35. But this one has a follow-up question. The question says, altogether, they have 55 marbles. Find how many marbles Nicola has. So altogether, so Y plus 35 should be equal to 55. So to find Nicola's, I need to do the opposite of plus 35, which is minus 35 on both sides. So 35, take away 35, leave us with just Y. 55, take away 35, so 0 here. 5 take away 3 is 2, so 20 marbles. And intelligently, and write your marbles there as well. Beautiful. So now we go on to another question on forming equations, expressions, and then we may also be asked to solve them. But let's see. So Graham thinks of a number x. What does he do? He adds 5 to his number, then multiplies the result by 7. He then divides the result by 4. Graham gets 28, an answer of 28. Write an equation this time. Remember, equation has an equal sign to show this. And then part B asks us to solve the equation we have formed in part A. So let's go. Graham thinks of the number x. So let's start with x. He then adds 5 to the number, so that's x plus 5. He then multiplies the result, so he's multiplying all of this by 7. That's important. Then he divides the result by 4. So let's multiply the number by 7, and then we're going to divide it by 4. So 7 times x is 7x. 7 times 5 is 35. So that's the result. He now needs to divide this result by 4. So one step at a time. And then he gets the answer 28. So equal 28. Part A is now completed. We have finished our equation, but we're now asked to solve it. So remember, we need to do the opposite of our operation. We want to find out what number did he start with. So here we have a division by 4. So have and do divide by 4. We need to times by 4. Then after we have a plus 35. We're going to need to take away 35. Then after that, we have a multiplication by 7. We're going to need to divide by 7. So let's go one step at a time. We need to multiply by 4 first. So we're going to do 28 times by 4. This side is being multiplied by 4 as well, but we know it's going to cancel out. So 28 times by 4. So 28 times by 4, guys, let me just use my calculator so that I can get through that quickly. 28 times by 4 is 112. So we will be left with 7x plus 35 equal to 112. We know how to use our column method, just trying to concise time here. We've done our multiplication by 4. We now need to minus 35 on both sides. So that cancels out, leaves 7x is equal to, use my calculator for this as well, 112 take away 35 gets me 77. Now I've done that, I need to divide by 7. So divide by 7, I get that. So put our answer here, x is equal to, so that cancels out, 77 divided by 7 is 11. Now we've arrived at our destination safely. So let's check our answer. When we substitute 11 in for x and carry out the operation, we should get 28. So 11 for x times, add to 5, 11 plus 5 is 16. Then he was supposed to multiply the result by 7. So 16 times by 7, 16 times by 7, 7 times by 6 is 42. Bring 4 here. 7 times 1 is 7, plus 4 is 11. See, we got back our 112 already. And then he divides it by 4. So if we divide our 112 by 4, so 112 divided by 4, 4 into 11 goes 2 times. 4 times 2 is 8. So that means 3 is left. 4 into 32 goes 8 times. So you can see we got back our 28. Beautiful. So we move on to the next question. Joan picks a number. We don't know the number straight away. I'm just going to call it X. She thinks of a number. She multiplies it by 2, then adds, so multiply by 2, then adds 10. Her answer is 4. What was the number Joan started with? So let's go. Thinks of the number. We don't know what it is. We chose X. So X, she should multiply this by 2. So that gets her so far to 2x. She should then add 10 to that. So that's 2x add 10. And we know she says the answer for that is going to be 4. So now, guys, what we've done is set up an equation. So again, we need to see what we have, what we need to do. So we need to plus 10, we need to minus 10. So minus 10 on both sides. So this will leave us with 2x since 10's cancel out. But be careful here, 4 take away 10 is minus 6. Dividing by 2 now. So times 2, divide by 2. So we get our x is equal to half of minus 6 is minus 3. So she thought of minus 3. And you can check that. I've shown you how to do that. Beautiful. So now, guys, we are going to go on to orders of operations. Okay? BIDMAS. Beautiful. I hope that you're really enjoying the session, guys. Make sure that you have put in the comment section to let me know the impact of this walkthrough, because I really love to get your feedback as well. Beautiful. Now we go to order of operations, and we know we're talking about BIDMAS. So we're asked to work out each of the following. So we got 3 plus, sorry guys, let me slow my roll. We got 8 plus 3 times in bracket 10 minus 6 squared. So we got our BIDMAS here. So I'm going to write it back here, BIDMAS. So we know we need to take care of our brackets first. So we're going to rewrite 8 plus 3, not touching that yet at all. So let's do our bracket. So in bracket, we got 10 minus 6, which is 4. We then need to go on to indices. So we need to do the powers first. So 8 plus 3 times by, from this bracket we get 4 squared. 4 squared is 16. So we don't have division. We now need to do our multiplication first. I know some people would run off to add. No, guys, we're multiplying first. So 8 plus 16 times by 3 is 48. Make sure you do your column method if you're not sure. So 8 plus 48 is 56. And again, make sure you check. Beautiful. So now we go to the next question. Again, we know we're going to do our brackets first. So let's rewrite what we're not using yet. So 6 plus 2 is 8. So divided by 2. So let's tick that off. We have done our bracket. Now we have 20 minus 4 times 8 divided by 2. So BIDMAS says we should do the division first. However, there is also BIMDAS. So it could also be BIMDAS. So the rule says whenever we have multiplication and division coming after each other, we can go from left to right. So we could have either chose to do 20 and minus 4 times 8, which is minus 32, divided by 2. Half of 32 is 16. So essentially, we are doing 20 minus 16, which is 4. But if you chose to do division first, let me show you that I'm talking the truth here. So 20 minus 4 times by 8 divided by 2. So 20, let's say you wanted to do your division first. You would have minus 4, 8 divided by 2. So you'll be multiplying that by 4. 20, 4 times by 4 is 16. So minus 16 still gives you 4. So BIDMAS or BIMDAS when multiplication and division comes beside each other. Beautiful. So we go to the next one. We got 5 squared. Even though we could simplify that, we're not going to do that. We're following the laws of BIDMAS to the T. So divided by, from the bracket, 3 times by 2 is 6. So we are now doing 18 divided by 6, which is 3. 5 squared is 25. Add them together, I get 28. Beautiful. Next, we go for our bracket, 12 minus 4 squared divided by 4 plus 6. So brackets first, 8 squared divided by 4, add 6. So 12 take away 4 is 8. That 8 is being squared. 8 times 8 is 64. So this will come on a non-calculator paper because we wouldn't give you this to put in a calculator because you get it all correct without being able to show us you know how to apply BIDMAS. So 64 divided by 4 adds 6. So we are to do division first because division comes before addition. So 64 divided by 4. So 64 divided by 4. Let's do it, guys, because maybe you don't know. I know the answer, but let's just do it together. So 4 into 6 goes once, remainder 2. 4 into 24 goes 6. So that's 16 plus 6, which gives us 22. And we tick that off. Beautiful. Now we go for our next question, which involves using a calculator. So we're asked to use your calculator to work out the following. Write down all the figures on your calculator display. Now, some people can still use the calculator and get it wrong, so I've put my calculator here to show you. So, first of all, we are working out the square root of 12.36, take away 5.12 divided by 2.97 squared. So this button here is your fraction button on your calculator. So once you press this fraction button, it will split it into a fraction. Okay, now you need to go for the square root. So this is your square root here. This one is your square root. You press your square root, then we're going to enter into our calculator. We're going to do square, so I press my fraction button, then I'm going to do square root 12.36 minus 5.12, and then in the denominator, so I'm going to press this down arrow to get to my denominator, so 2.97, and then I press my square button, which is this one, and then go across until my equal sign is, my dot is blinking here, then press the equal, and I get full calculator display, mean everything without rounding. So I got 0.3050397136. And then you just check your digits to make sure they are correct. So we're going to do the next one, work out bracket. So we know we have to put bracket. So this is your bracket. You will press your bracket on your calculator, then press 3.15, take away 0.28, then you close your bracket with that one, press your square button again, then press minus, and then 4.076, press equal. So I got 4.1609, full calculator display. Now some questions could also ask you to round. So we move on with two-way tables. So a cinema records some information about the visitors they have one weekend. So we can see here we got day, Saturday and Sunday, got a total, we got adults and children, and also the totals. We're asked to fill in all the missing values. Now, when we're doing two-way tables, we always look at a row or a column where we only have one missing variable. So for example, we're going to start off with adults for Saturday. Okay, so adults, Saturday. To get the adults for Saturday, we could do the total here, which is 212. We're going to subtract 115 from that. So we're going to put that in our calculator. 212, take away 115, that is equal to 97. So sometimes you get this on your calculator paper, okay? But if not, I've taught you a lot of how to do your column method, so we check that off. Next, we need to find adults for Sunday. So let's go, adults, Sunday, and we can do that now because we have filled in this one. So the total is 143, and we're subtracting the 97 for the Saturday from that. Put that in our calculator. 143 take away 97, that is equal to 46. So we fill that in. So now we're going for another space. We can find either our Sunday total here, or we can find our total for the children's column here. So I'm going to do 360, take away the 143 here to find this one. That will give us the total for children. So children total. And the total for children would then be equal to 360 take away 143. Put that in our calculator. So 360 take away 143. That is 217. So this is 217 here. Beautiful. Now I can either find any one of these ones. So I can find children Sunday. So let's go. Children Sunday. And to find children for Sunday, I need to do the total here, which is 217. And I'm taking away 115. Put that in my calculator. So 217 take away 115. That gives me 102. So we put that in our table here. So 102. Final column we could get from either adding 46 plus 102 or doing 360, take away 212. So Sunday and the total here would be, let's just write Sunday total. Notice how I give my work a very clear line of thought. Well done. So we need to do 360, take away 212. So 360 take away 212. We put that quickly in our calculator. That gets us 148. Beautiful. So guys, when you're finished, you can just use your calculator to make sure when I add across, I get 212. When I add down, I get 143. When I add across, I get 360, and so on. Beautiful. So now we move on to proportional reasoning. So we're told here, Lena buys balloons, hats, and masks for a party. Write the missing numbers in the table. So we can see on the table, we've got packets of balloons and the cost, £4.95. The numbers bought was 5. We don't know the total. Hats, £3.20. We don't know how much was bought, £41.60. Mask, we don't know the cost of each, but we know the number bought and also the total. So what we need to do now is to focus one row at a time. So packets of balloons, each of them cost £4.95. We know that they have bought 5. So we can easily find the total. So let's go for packets of balloons. We could just wrote balloons anyway. Okay, so £4.95 for one, and we have bought 5, so we are multiplying £4.95 by 5 using my calculator. £4.95 multiplied by 5, that gets me £13.75. Fill that in on the table. £14.75. Let me just move away that tiny spot. It cost a little issue for anyone at all. Okay, so next one, we are on to hats now. So for the hats, £3.20, we don't know how much, but we know the total. So therefore, we can do the total for £1.60 and divide that by £3.20. Put that in our calculator. So £41.60 divided by £3.20. And that gets us to 13. So there were 13 of them that was bought. Last one, we got our masks. So for the masks, we don't know the cost, but we know the numbers bought and we know the total. So we can just do £19.50 total divided by how many was bought. This, guys, we've practiced just now our division by 10. So we just need to go one place backwards. So that's £1.95. We put that in on the table. Absolutely brilliant. So now, guys, we are moving along to types of numbers. So Henry thinks of a number between 1 and 20. He thinks of the number 12. For each question below, tick yes or no for Henry's number. So the number is between 1 and 20. And the number is 12. So we're focused on 12. He thinks of the number 12. Is it an even number? The answer is yes. Can be divisible, but it is divisible by 2. Is it a multiple of 3? So can 3 go into 12? Yes. So the answer is yes. Is it a factor of 18? So can 12 go into 18 without a remainder? The answer is no. So we got 2 yeses and a no. Part B says, Ashraf also thinks of a number between 1 and 20. The table shows information about his number. So is it an even number? No, the number is not an even number at all. Is it a multiple of 3? Yes, it's a multiple of 3. Is it a factor of 18? No. What is Araf's number? So multiple options there, but we know it will never be an even number. A good practice here would be to list the numbers between 1 and 20. Strike out all the even numbers. That's not a possibility since it's not an even number. Is it a multiple of 3? Yes, it is a multiple of 3. So we could also write down the multiples of 3. So multiples of 3, but remember, we do have multiples of 3. That's an even number as well. And is it a factor of 18? The number is not a factor of 18, so we can't choose that. So I'm thinking, I know it can't be even, but it could be odd or it could be prime numbers. But let's focus and get it down more. Odd number, do we have odd numbers that are multiples of 3? Yes. So our best bet here is a prime number. So a prime number will not, the only even number that's prime is 2, but it doesn't fit the other criteria. So we know it could be 19, it could be 5, it could be 7. So any one of those that you pick, prime numbers there, would be a criteria. So I'm going to say my answer, I want to go for 7. Let me choose 7. So 7 is an option. So it could be 5, 7, 11, and you know your prime numbers. Hopefully you do. Okay, so we move on now to product of primes. So we're asked here to write 90 as a product of its prime factors. So we know all the factors that are prime numbers. So we start with our factor tree. So we can go for 3 times by 30, circular prime number, 3 is a prime number. Bring 30, 30 can be 3 times by 10, 3 is a prime number. Break 10 out into 2 times by 5. Now we got all our prime numbers. So it's 2 times 3 times 3 times by 5. We check. 2 times 5 is 10. 10 times 3, 30. And times by another 3 is 90. If we were asked to put this in powers, then it would be 2 times by, so in index form, it will be 3 to the power of 2 times by 5. We weren't asked, so it doesn't really matter the representation. Now we go for another question. The following numbers have been expressed as product of their prime factors. 48 is equal to 3 times by 2 to the power of A, and 56 is equal to 7 times 2 to the power of B. What are the values of A and B? So guys, what we have to do here, we've got to find the prime factors of 4A, put them in this fashion, and then see what A is. So 48, we could do 2 times by 24. We could then do 2 times by 12. We could then do 3 times by 4. And then we could do 2 times by 2. So let's put it all together. So 48 would be equal to, we got 1 3 there. So 3, let's put it in the same order they gave us, the 3 first. And then 1, 2, 3, 4 2s. So 2 to the power of 4. So we can see here that our power of 2 is a 4. So let's do 2 to the power of A is equal to 2 to the power of 4, since those are the matching ones that we found. So therefore, we can conclude that A is equal to 4. Beautiful. So now we tick that off and we move on. So ticking that off, let's do the other part. We got 56. We now need to break it apart. So 56 is 7 times 8. Circle the 7. 8 is 2 times by 4. Break 2 again. 2 times 2 gets us to 4. So 56 is equal to 7 times by 2 to the power of 1, 2, 3. So again, 2 to the power of 3 matches with 2 to the power of B. So B therefore is equal to 3, and we tick that off. So B is equal to 3. Absolutely fantastico. So we go to our next question. Now we're going to find highest common factor and lowest common multiple using our products of prime. So find the highest common factor of 60 and 114. So we're going to break it down since we're using factors and multiples for lowest common multiple here and highest common factor. We're going to use our prime factors. So we could do 2 times by 30. So we go again, 3 times by 10. We go again, 2 times by 5. So for 60 is equal to 2 times by 2 times by 3 times by 5. We check 3 times by 2. 3 times by 5 is 15. 15 times 2, 30. 30 times 2, 60. We're sure we're correct. We do that for 114 as well. So we can do 2 into, so if you can use your calculator quickly, guys. So for that one is 2 and 14 divided by 2. I'm just trying to go quickly. So that is equal to 57. Then we can check. 3 can go into this. How do I know? 7 plus 5 is 12. 12 is divisible by 3. So 57 is divisible by 3. Just going to do 57 divided by 3. That's equal to 19. Both prime numbers. Beautiful. So 2 times by 3 times by 19 is 114. So therefore, to find the highest common factor, I'm just going to put them into a Venn diagram because question could ask you to do that. So 60 and 114. So we're going to put the common things in the middle. So 1, 2 from both is common. There is no more 2's here, but there is a 3 that's common. We put that in the middle. So what's left of 60 is 2 and a 5. What's left of 114 is 19. So we get our highest common factor by multiplying the terms in the middle. So 3 times 2 is 6. 6 is the highest common factor. Beautiful. So now we're going to go to the lowest common multiple of 70 and 56. So 70, we could do 2 times by 35. Then we could do 5 times by 7. Done. So 70 is 2 times 5 times 7. We then go on to 56. 7 times 8 is 56. We did that earlier. So then we go for 2 and 4, and then 2 and 2. So therefore, 56 is equal to 2 times 2 times 2 times 7. So 2 2 is 4, 4 2 is 8, 8 7 56. Go for my Venn diagram. So I'm putting 70 here and 56 here. Okay? So common is a 2. We put 1, 2 in the middle. No 5 common, but there is 1, 7 that's common. So of 70, 5 is left. Of 56, a 2 and a 2 is left. So lowest common multiple we get from multiplying everything in the two circles. So 2 times 2 times 2 times 5 times 7. So if we put that all in our calculator, so we get 2 times 2 times 2. Let me make sure I haven't missed anything. Good. So 2 times 2 times 2 times 5 times 7 is 280. Well done, guys. Beautiful. So now we move on to roots and powers. So quick questions. What is the square root of 121? So square root of 121, every square root has two values, positive 11 and negative 11. Why is this so? Negative 11 times negative 11, two negatives multiplied together is also a positive. So always remember that. Every square root has two answers. So now I'm asked, what is the square of 9? 9 squared means 9 times 9, which is 81. What is the cube of 3? 3 cubed means 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. Beautiful. Now explain why the square root of 89 must be between 9 and 10. Non-calculator question. So square root 89. What we need to do is to find out the square number before and the square number after 89. So the square number before 89 is 81, and the square number after 89 is 10. So if we find the square root of 81, it's 9. Square root of 100 is 10. So we need to explain and say, do this. Make sure you got your numeric calculation, but then say, because it lies in between the square root of 81 and the square root of 100. Beautiful. Next question, same principle. Explain why square root 30 lies between 5 and 6. So again, square number before 30 is 25. Square number after is 36. So this gives me 5 and this gives me 6. So then you say, because it lies between square root of 25 and the square root of 36. Absolutely brilliant. We move on to ratios. So we're told that Sophie has 60 pencils. The ratio of her sharpened pencil to her blunt pencils is 4:1. So let's go. Sharpened to blunt is 4:1. How many sharpened pencils does Sophie have? So the first thing we need to do is to find the total of our ratios. So the total is 4 plus 1, which is 5. We know that the total pencils is 60. So we can find one ratio part by doing 60 divided by 5, which is 12. So we want the ratio of the sharpened pencils. So sharpened will be equal to, the sharpened part in the ratios is 4. So 4 times by 12 is 48. So we do our 4 times by our 12, which is 48. We end appropriately and say pencils. Next question. Alex and Thomas share 30 sweets. They divide them in the ratio 3:2. So let's go. Alex, Thomas, 3:2. How many sweets does Thomas have? Again, total of ratio parts is 3 plus 2, which is 5. Total sweets, so one ratio part will be equal to total sweets divided by the total ratio parts. So 30 divided by 5 is 6. So we want to find out Thomas's share, which is 2 parts. So 2 times 6 is 12. So Thomas has 12 sweets. Beautiful. Hope he doesn't eat them all, guys, because too much sweet isn't good at all for Thomas. Neither is it good for you. Okay, so we go to another ratio question. This time we're told ratio of numbers of girls to the number of boys in a school is 9:10. So girls to boys, 9:10. This question says there are 900 boys. So under boys, let's put 900 in the school. How many girls are there? So now we need to find a link between the ratio parts and the number of boys. So one part of our ratio is 900 divided by 10, which is 90. So we know we are multiplying by 90. So the girls then will also be 90 times by their ratio part, which is 9. So 9 times 90. 9 times 9, 81, and 0 at the end. So girls is 810. Final question on ratios. The ratio of lemon sweets to strawberry sweets is, in a tub, is 5:3. Okay, there are 120 lemons, put that under straight away, sweets in the tub. How many strawberry sweets are there? So again, one part of ratio, how did we get from 5 to 120? 120 divided by 5. Put that in my calculator quickly. 120 divided by 5 is equal to 24. So therefore, for the strawberry will be 3 times by 24. 24 on my calculator, so just times 3. That's equal to 72 strawberry sweets. So strawberry, good. 22 strawberry sweets. Make sure you end intelligently. Beautiful. We go on to coordinate geometry. Here are a set of coordinates. We got 2, 1, 4, 3, 6, 5, 8, 7. Describe the relationship between the x coordinates for part A. So let's get all the x coordinates we got. So remember, the x is the first one in each bracket pair. So we got 2, we got 4, we got 6, we got 8. So we can see the relationship we are adding to all the way through. So the relationship is that they increase by 2 each time. Well done. So next part, describe the relationship between the y coordinates. So let's write the y coordinates down. It will be 1, 3, 5, and 7. To get from 1 to 3 is 2. So again, guys, these ones are doing the same thing as well. So they increase by 2 each time. Each time. Well done. So we're all going up by 2. So that's what you would do should you see a question like that. Now we're on to linear graphs. So we're given the first question, ask us to plot the point with the coordinates 1, 3. Remember, x comes first, or we run before we jump or stoop. So we need to find 1 along x and go up to 3. And we were told to label this point A. So we write A there. Beautiful. So now we are told to write down the coordinates of the midpoint of BC. So this is BC. We're looking for the middle of it. We can see dead on here is halfway. So coordinates we need for x, it's 1. But we didn't move on the y, so that's 0. So that's 1, 0. Finish that one off. Now we go to the next question. So the sides of the square below are 7 units long. Each side of the square is parallel to the x-axis. So parallel means it runs in the same distance, same distance away. Okay, parallel lines are same distance away throughout their length, never meeting. Okay, so parallel to the x-axis, each side of the square is parallel to the x-axis. What are the coordinates of the point G? So we need this coordinate here. Now, key point, guys, is that we know the distance along the square is 7 units. So if we want the x-coordinate of G, we need to add 7 to the x-coordinate of E, because all of this distance is 7 along. So to get from 1 to the next coordinate here, which will also be the x-coordinate for G, so the x-coordinate for G would be equal to 1 plus 7. So the x-coordinate is 8. Now, remember, the square is 7 along. So if I know here the y-coordinate, I'm sure for F, so this is 8, 4 for F. So I know the y-coordinate here is 4. So that means I need to go for the y-coordinate of G. If it's 7 down, I need to do 4 take away 7, which is minus 3. So the coordinates of G then are 8 for the x and minus 3 for the y. Absolutely fantastic. Now we go for another question where we are plotting points and drawing lines. So write down the coordinate of the point A. I check. I must do my x coordinate first, which is 4. My y coordinate is minus 2. So it's 4 minus 2. Next, I was told that on the grid, I need to mark a cross with the point 4, 3 and label it B. So I go 4 for x, 3 for y, and label that B. Beautiful, tick that off. On the grid, draw the line with equation x equal to minus 1. So I go on the x-axis, look for minus 1. I need a straight line that's going to be vertical. Going through that, I will now label that x equal minus 1. Beautiful. Remember, a line equal to x equal to something is a vertical line. So I know you guessed it that the y will be horizontal. So let's go. Write down the coordinates of A from this grid. So we got 5 for x, and for the y, we got minus 2. Beautiful. Nice and easy there. On the grid, mark with a cross, minus 1, 3, x first, minus 1, up for y, 3, and label that B. So that's B. Now, on the grid, draw the line of the equation with y equals 6. So on my y-axis now, looking for that, then I need to draw a straight line across, label y equal to 6. Spot on. Beautiful. So now we go to drawing a linear graph. So we're asked here to complete the tables of values for y equal 2x, add 1. There's just one missing element on the table, nice and easy to fill. So y equal 2x plus 1, when x is 3, I will do 2 times by 3, add 1. 2 times 3, 6 plus 1 is 7. So I've completed my table. On the grid, draw the graph of y equal 2x plus 1 for values of x from minus 1 to 3. So basically, just plot these points onto the grid. Let's go. Minus 1 to minus 1 is here, guys. Tick that off. 1 to 3. 1 on x, 3 on y is there. Tick that off. 3 on x and 7 on y is here. So we know we must use our ruler and a pencil to make that straight line. And then label our graph. Y equal 2x add 1. We know if we don't get a straight line, something is wrong. Okay, so we got another coordinate geometry question here. Below, ABCD below is a square. What are the coordinates of the point C? So we need to focus on this coordinate here. Okay, now it's a square, guys. So again, a higher order question similar to the one we did before, but now we've got to think a little bit more. So I know one thing I'm sure about C is that if the x coordinate of D here is 10, we're still in that same line. So the x-coordinate of C is also going to be the same. Now I need the y-coordinate. So I need to first of all find out, because it's a square, it's the same distance from A to D as it is from D to C. So what I need to do here is to find out by subtracting the x-coordinates, I can find out how long is one side of the square. So 10 take away 3 is equal to 7. So therefore, I know that the distance from D to C has to also be 7. And I know that will be in terms of the y-coordinate since that's the one that goes up. So if this one is 5 at D, and I know this side of the square is 7, then 5 plus 7 gives me my y-coordinate. So the coordinates of C then are 10 for x, and 12 for y. So the coordinate is 10, 12. Now at this point, I would say pause the video and try the next one to see if you got it. Okay? Hopefully you stop and do that. Now, same ABCD, below is the square. What are the coordinates of C? So same principle. So you should have found your x first by doing 10 take away 2. We know the square is 8 along. So that means I know the coordinate of the x for C is also 10 in the same line for x. And then 8, this one is 4. So 4 for the y coordinate, and I know I'm going up by 8. So that's equal to 12 again. So the coordinates then of C is also for this question 10 for the x coordinate, and for the y coordinate it's 12. Beautiful. There we go. Absolutely fantastic. Now we've got areas of rectangles. So the area of a rectangle is 60 centimeters square. Its length is 15 centimeters. What is the length of its width? So I know the area of a rectangle is the length times the width. So that means I know that the area is 60 centimeters squared. That's equal to the length times by, which is 15, times by the width. I don't know what it is, but I know this is centimeters as well. So I know that I'm multiplying by 15. So let's simplify this. 60 centimeters square is equal to 15 W centimeters. So I need to divide by 15 on both sides since I was multiplying W by 15. We've done a lot around equation. This should be good for you. So W centimeters then is equal to 15 divided by 6, which is 4 centimeters square. So if I divide by centimeter here, then 1 centimeter cancels out with the centimeter from there. So 4 is equal to W. So W equal 4. Okay, guys. So we're going to go on to our next question. So the area of a rectangle is 48. Draw one possible rectangle on the grid. So this one came in automatically, guys, but we had to choose two numbers that multiply to 48. This just flew in without my knowledge. So we could do 6 times by 8 for 48. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. So just two factors of 48 that times to give us 42 numbers that times to give us 48, and we will draw our rectangle that way. Absolutely brilliant, guys. I'm so proud of you for sticking with me through this revision, but I really tried to cover a little bit of everything that you have learned this year. Beautiful. So now we're on to types of triangles by sides. So we're asked to name each triangle seen below. Test yourself and write the answers down and see if you got them all. So if we look at the sides, we can see 1 stroke, 2 stroke, 3 strokes on this, which means none of them are equal. I bet you guess it is a scalene triangle. Well done. So your answer for that one should be scalene triangle. No sides equal. For the next one, there are 2 sides equal. What's the name? It is an isosceles triangle. 2 sides equal. And for the yellow triangle, all 3 sides have the same line. So all 3 sides are equal. Equal, equilateral, equilateral triangle. All sides equal. Beautiful. So we go on to types of triangles by angles. So we check inside. We're looking to see the sizes of the angles. So in the first one, we can see all of the angles here are seemingly less than 90 degrees. So I bet you guessed it right. It is that little cute one. It is an acute angle. See what I did there? All the angles are less than 90 degrees. Now we go on to the next triangle. We can see clearly if we draw a line straight down, that's 90. So this angle has at least one angle here greater than 90, and that is going to be obtuse. So an obtuse angle triangle will have one angle that is greater than 90 degrees. And then this one, the right angle gave it away. Yes, guys, this is our right angle triangle with one angle being a right angle. Now we go for areas of triangles. So we're asked here to find the area of each triangle. So we know that the area of a triangle is equal to the base times the height divided by 2. By now our multiplication skills have grown significantly, so this will not take us long at all. So the base of our triangle here is 9 multiplied by our height, which is 4, and we need to divide that by 2. So 9 times 4 is 36, and dividing that by 2, half 36 is 18. And remember, we end with centimeters square, and that's because centimeter times centimeter makes centimeters squared. Beautiful. So just practicing this question again. Base times height for this other triangle divided by 2. Make sure your height has to always form a right angle with your base. So if it is not perpendicular or forming a right angle, it's with a right angle with the base, it is not your height. So some questions could have put the 8 here. You have to make sure you know that would not have been the height. It must form a right angle. So 8 times 12 divided by 2. So 8 times 12 is 96, divided by 2 is 48. However, if you didn't know your 12 times table, you could have done dividing by 2, divide 8 by 2, which is 4. Now you could do 4 times 12, which is simpler, which is 48, and the unit is centimeters squared. Fantastic. Now we go for the area of the trapezium. So the area of a trapezium is, I've put that formula in for you. So the area of a trapezium is half A plus B times the height, where A and B are the parallel sides. So parallel sides have the lines on there, so that's 10 and 30. So we just, and the height always again forms a right angle. See that? That's 20. So let's put this in our formula. Half times by A. So A is either 10 or B, doesn't matter at all once it's the two parallel sides for A and B. So it's 10 plus, we look at the formula, plus 30, and then we multiply that by our height, which is 20. So 10 plus 30 is 40. So half of 40 is 20. So we're doing 20 times by 20. I hope you know your square numbers. 20 times 20 is 400. Unit is centimeters squared. Beautiful. Another similar question. So half of A, so this time parallel sides are 7 and 9. So work out the area of this trapezium. 7 add 9, and the height is 4. So half of 7 plus 9 is equal to 16 times by 4. So half of 16 is 8, and 8 times 4 is 32, and the unit is centimeters squared. Beautiful. So guys, we have just 2 questions to go, and the first one is on area of compound shapes. So what is the area of this shape? So we know when we get a compound shape, that's 2 shapes joined together. Now we have to split the shapes in 2 sections and work the areas out, then add them together. So the easiest way to split the shape, what is the area of this shape? We need to split this across. So let's call the large one shape 1 and this one shape 2. But we need to find out the length from here to here on the second one. Now, if the distance from the top of the shape to the bottom is 10, and from here to the bottom is 7, to get the side here, I need to do the 10, take away the 7. So this length is 3 centimeters. Now that we've done that, we are going to go along. So the area of shape 1, length times by width. So the length, so we got 7 and 10. So 7 times 10 is 70. So 7 centimeters times 10 centimeters. 7 times 10, 70. Centimeter times centimeter is centimeters squared. So area 2. So area of shape 2. So I'm just going to say area of, let me just fix this, guys. So get my pen back. So area 2, I'm just going to say area 2. And that's equal to, I've got 4 and 3, remember? So 4 centimeters times 3 centimeters. 4 times 3 is 12. Centimeter times centimeter, centimeter squared. But remember now, it's the total that we're after. So we need to do 70 centimeters squared plus 12 centimeters squared. 70 plus 12 is 82 centimeters squared. Beautiful. Now we go on to our T shape. So we got a compound shape again, and we are working out the area. It's a T shape. We still do the same thing. So we can split it across this way. Be careful now. Make sure you got all your measurements. So for shape 1, I've got 5 and 5. Nice and easy, does it? But let's get the dimensions. So across here is 4. Across here is 3. And we know that here is 5, so here is 5 as well. So to get all the way across T, we need to do 4 plus 5, which is 9, plus 3 is 12. So for shape 2, we're going to be doing 4 times by the 12 here. So let's go. Area 1 is equal to 5 times 5. Area 1 equal to 5 times by 5, which is 25. And it's going to be centimeters squared. Area 2 is going to be 12 times by 4. 12 times by 4 is 48 centimeters squared. So the total area will be equal to 25 add 48. So 5 plus 8 is 13. And 4 plus 2, 6 plus 1, 7. Don't forget your unit now, centimeters squared. So 73 centimeters squared. Now, guys, it's time for our final question. Absolutely fantastic, guys. I'm so proud of you. I'm so proud of you. So this time we're asked to find the area of the shape. Again, by now we know the drill. We're going to have to separate it, but this time we're getting a triangle and a rectangle for shape 1 and 2. So the base of the triangle will be the same since the sides of the rectangle, matching sides are the same. And we know the height is the green portion of 5. And then we got 8 and 6 for the rectangle. So let's go. Area of triangle is equal to my base times my height divided by 2. So my base is 6, my height is 5, and I should half that. 6 times 5 is 30. Half of 30 is 15, and the unit centimeters squared. Area of rectangle is equal to length times by the width, which is 8 times by 6. 6 times 8 is 48 centimeters squared. So total area would be equal to 48 add 15. So let's go. 8 times 5, 13. And we bring 1 over. 4 plus the 2 here is 6. So the answer then is 63 centimeters squared. And that, guys, takes us to the end of our revision. You will agree that we've covered quite a bit of topics. And I'm sure now you are far more confident of facing your exam, both your paper 1 and 2. Should these questions come, we know that based on our national curriculum, these are the topics we do at year 7. So once you've mastered these, I'm so confident, guys, that you are going to do exceptionally well. And I'm so proud of you for getting all the way through. I know the video was long, but I wanted to make sure that you covered at least most, or even for some people, it may be all that you've done in your year 7. Look at you going on to year 8 soon. So proud of you guys. So I hope that you liked the video. I hope you drop me a comment and make sure that you share the video. I wish you all the very best in your exam. And until the next time, guys, thank you so much for watching.